I'm going to show some size comparisons from the smallest thing we can measure, which is the Planck length, to the largest thing we can measure, which is the observable universe. This brings up a question though, and that is how many times would you need to cut the observable universe in half to get down to the Planck length? Observable universe is 9 times 10 to the 26 meters. Planck length is 10 to the negative 35th meters. You can pause the video if you want to do your own guess or make your own calculations. Otherwise, on the next page, I'm going to show some comparisons and then I'll show the answer. Planck length times 2 times 10 to the 20th power will give you the diameter of a proton. Take that times 5 times 10 to the 4th power, or 50,000, to get the diameter of a helium atom. Helium atom diameter times 17,000 will give you the diameter of a Staphylococcus bacteria. Take that times 2 million to get the height of a human. Height of a human times about 5 million will give you the diameter of the Earth. Take that times about 100 to get the diameter of the Sun. Take the diameter of the Sun times about 40 million to get the diameter of the solar system. The solar system boundary has a few definitions. One is to Neptune, another is to the trans-Neptunian objects such as Pluto and the Kuiper Belt. Other definitions go out to the Oort cloud, or about halfway to the nearest star, which would be about 2 light years, so I'll use that definition. So 2 light year radius times 2, because we want the diameter, turn years into days, days into hours, hours into seconds, seconds into the speed of light, which is 3 times 10 to the 8th meters per second. That gives 4 times 10 to the 16th meters. I use the same conversion equation to convert from light years to meters when I did the calculations for the Milky Way galaxy and the observable universe. Take the solar system times 23,000 to get the diameter of the Milky Way. Take that times about 1 million to get the diameter of the observable universe. Take the diameter of the observable universe, divide that by the Planck length, you'll get 9 times 10 to the 61st, which means there are that many Planck lengths in the diameter of the observable universe. Take log base 2 of 9 times 10 to the 61st, so that means 2 to what power equals 9 times 10 to the 61st. That equals about 200. This means to go from something so large as the observable universe that takes light almost 100 billion years to cross, down to something so small as the Planck length, which is less than 1 quintillionth the diameter of a proton. You only have to cut it in half about 200 times. And that is the power of 2 to the nth exponent.